How's it going, everyone? Welcome. Elvira Gonzalez. That's right. So, I want to now explore this particular model of union and narrowing, right? As to illustrate the key aspect of Typescript, especially when you have a system that you need to represent some piece of data to the ever evolving business nature. And now, by exploring is the way of how you can define is this wide types or narrow, this wideness and narrowness of your data. So a lot of the time, this will give you is the ability to first get intelligence in your ID. Seconds, that errors happen is at compile time or at run times, and also that you can use some of these quick fix options menu that the ID provide to you. And the whole point of this is to create now robust and scalable applications that are easy to maintain. And I emphasize a lot in easy to maintain or to enhance or remove some stuff is because a lot of the times, based on my own experience, it is quite hard to make a simple small change. And that is not only because most developers they don't follow certain patterns, most of them they don't even aware, especially on the web, on JavaScript or on TypeScript, about the patterns or the common the patterns to solve specific problems, which now the community and the industry has shown that this is the way of doing that, because now we have this standard way of writing and reading our code, and anytime that we need to some changes, it'll just is easy to do so, and that also translating to a huge impact on your business and revenue and margins and revenue and from user conversions from user conversions to from user retentions to conversions. All right, so from all of these leads, sale potential, Jesus, sorry. So, from all of this business aspect, whether it's margins or you have now this huge funnel, and you have all of these sales leads or prospect, and then as you narrow down all of them, you ultimately now have your own clients, right? Or the user conversion in the case of business, web development business or web business. So, so this is great, all right. And in order to explore more about this, I do want to now is check out the narrowing or unions and narrowings. And first, by exploring is the null, how you can represent nulls, how you can now combine or work with nulls in TypeScript, all right. And then that is also nasty in JavaScript, because unfortunately now for legacy reasons, null is a way of how you can. So the value of null or the type of null is not null, is an object. Again, that go beyond the scope of today's video. The TL is that is the fact. All right, that's a fact. So that's right. And also as we look at how can or this typing annotations on the assignability and unions, all right, how you can now is for a basic example like strings and numbers, so how you can now represent is a specific value with these specific types, right? And sometimes you want is to now compose or union several of these small different types. So the idea here is that anytime that you assign or put a or you type the shape of this value, right? So you have now this idea of what you're putting here is something that is broad or something that is narrow. And a good example of this is when you need to use is these typed literals, all right? So in the case of the HTTP code like this, right? So a lot of the time you can say, hey, I can use this, all of these specific codes, and because I do want is to now cover small subset of examples here. So whether if I do this and say, I can grab all of this as error status code. Unfortunately, this is not working, which is something that I really hate about this, right? That it doesn't give me that. But what you can say is define a type error, which is now this this subset of this huge, or this is a subset of types of possible values here. You can also define it here is the success code, right? Like this, and you get all of these values here. And then as this wide type, define all of the possible combinations here. So in our case, we can say error code or combined with the success code here, right? And if you want to use a specific one, you whether you define your own types like this error code, all right, and here you say the success code, and this word like charms, or you can now go with this specific type utilities, which all of this what it's doing is to generate is the proper type, similar as functions generates values. This utility function, or known as the genetics, generate types. So that's great, because another question is that how many or how big can a union be? That's a good question. Right? So for example, in the case of alphabet,
how big can a union get in TypeScript? Well, we've got this alphabet type, which is basically a massive union type of all of the letters in the alphabet, so 26 in there. And we've got a type down the bottom here, which is too big. This is using some advanced type syntax to basically create what it's trying to do is it's creating a string where
this specific type is creating now a string where each one of those characters can be only part of the English character, right? So it can be either is A or B or C or D in the first spot, and then on the second spot the same A, B or C, or you name it, and on the third spot it can be all the 26 combinations, and the same for the fourth spot here, right? So you have now 26 times 4 combinations, or in other words you can say 26 times 26 times 26 times 26.
Each of the letters in the alphabet can potentially be in each slot here, so it's like 4 letters long, each of the ones of the alphabet. And you might think TypeScript will probably be able to handle this. Well, if you think about it, it's like 26 here, times 26 times 26 times 26, so 26 to the power of 4, and that creates a union type that is too complex to represent. So TypeScript sometimes just sort of like goes, oh, please don't make me do this. Why are you making me do this? Because usually a better way to just represent this is just with a string. You don't need to be too precise here. And so there is an upper limit on how big a union can be in TypeScript, and you'll sometimes hit this error. But usually only when you're doing something that you probably shouldn't be doing. Anyway, I thought I'd include this because it's pretty fun.
Yeah, it makes a lot of sense. It makes a lot of sense. If you are now creating a type that is trying to cover all of these possible combinations, so TypeScript say no. Let's go with a more broad type here. Okay.
Let's talk a little bit about how literal types resolve with wider types. You can see here that we have a getResolvedIconSize function, which is taking in an icon size parameter of either small, medium, large, or string. This means that if you pass in small, it's going to return 16, or return 32 if it's medium, or return 48 if it's large. Otherwise, it just returns the icon size. Now, you would think, okay, we've got our icon size here. It means that we can, pass in each of these. But let's think about the assignability chart that we saw earlier. Here we've got our icon size here.
Resolving literal types and wider types. Okay, so why am I looking at this? Because these literal types are useful when you need for autocompletion features, right? So if you define now a finite set of possible values, okay, so these features allow you to show you this by using the autocomplete feature. That's good, but sometimes you want to also include any other possible strings. And let's see how these things work, which is literal versus wide types.
Icon size function, which is taking in an icon size parameter of either small, medium, large, or string. This means that if you pass in small, it's going to return 16, or return 32 if it's medium, or return 48 if it's large. Otherwise, it just returns the icon size. Now, you would think, okay, we've got our icon size here. It means that we can, pass in each of these. But let's think about the assignability chart that we saw earlier. Here we've got small, medium, large, or string at the top here. And if you think about it, string is assignable to that, so is small, medium, or large. And so if you think about it, everything inside this top area here can just be represented by string. And this means then that if we take a look, basically all of the actual literals, when they're in a union with their wider type, they get cancelled out. And TypeScript sort of forgets that they exist because it doesn't need to really keep track of them. So all of these arrows of like small here, really because they're assignable to string, then this whole thing at the top here just counts as a string. And we can see this in action here. So getResolvedIconSize here, even though it's got all of this sort of stuff when you hover over it, which is quite useful, it won't give you autocomplete for small, medium, or large here, which is a little bit annoying if you think about it.
I do want to make a quick pause here because this is a very important moment to actually go and read about this particular section of the You Don't Know series written by Kyle Simpson. So shout out to Kyle Simpson here. Where it explains things like this. So in our case, it's type and grammars, right? This was like updated 2 years ago. Chapter 3 years ago. Chapter 2 and chapter 2 fixed typos. Right? But the point is that when I explore the primitive values and the possible values that we can have in JavaScript, whether it's undefined, null, objects, or let's go for the primitive, right? So undefined, null, boolean, string, numbers, symbols, big int, right? And this is just the primitive values, like this, so, or non-object values, right? So once I explore about this and the anatomy of these specific values, whether it's number that is follow the IEEE 7054 spec that describe how this thing is gonna be represented on the memory, okay, and that is using now a mantissa and an exponential. Again, that go beyond the scope of today's video because it's all about a string. and a string is the universal interface here. I didn't say that. I just paraphrasing what the C. Dennis Ritchie, I think it is Dennis Ritchie. Yeah, you got it. So I'm just paraphrasing what Dennis Ritchie actually mentioned, that at the end of the day, right? Um, well, um, holy moly, Bill Clinton, god damn it, bitch. Uh, in any case, I thought that he mentioned that. All right. uh, so, but in any case, so yeah, the universal interface, at least for computers, is string, right? So, in that regard, so once I explored about what the French toast is and string value from this Kyle book, the Kyle Simpson here. So it says that yeah, it's a sequence of characters that can be one or more, right? So like this, or even using my name, and then you can assign that to an identifier. So JavaScript don't distinguish a single character as a type, as some language will do, like this, or is just a string like this. String can be delimited exactly. So some other language specify that hey, this is just a character, or even some database engines say hey, this is just a character, or a long string, right? Or a character set. Uh, so string have an intrinsic length which corresponds to how many code points actually code units more than in a bit they contain, right? So this does not necessarily correspond to the number of visible characters present between the star and the end delimiters, aka the string literals. So it can sometimes be a little confusing to keep straight the difference between a string literal and the underlying string value. So pay close attention. So in other words, that value is not representing is the visual the visual representation of that sequence of that string. Is representing is an internal representation of this code point, all right, of how each one of those characters actually represents. So this is just to mention this briefly. So if you put a, for example, do things like, hey, I wanted to add now an emoji. How the French toast add an emoji here? This one, this one, this one. Really? Oh, there you go. So you can say, hey, this now Argentina, right? If I say length, it's a invalid token because I need to wrap this as a string. And then it says like, what the French toast is this? Is 4. You know, again, this visual representation of a character does not is which is something that is, well, again, that go beyond of today's topic, but this is what it is, right? It's not hard to actually try to define all the possible symbols and to match that to the same length, because you have to create is a huge table where you are mapping each one of those different symbols, right? And how you can represent those symbols matters here, which is when I went through this, or when you encoding those characters, what type of character encoding does GS use for string characters? So you have probably heard of Unicode or perhaps the UTF-8 or 16. If you're like me, before doing the research, it took to write this text, okay, you might have you might you might have just hand wave and, and decided that all you need to know about character encoding is JavaScript strings. But that's not even close, because it turns out that you need to understand how a variety of aspects of this Unicode works. This representation of this, how now the JavaScript engines encode those characters, or how it map this. And even to consider concepts from this, like 2-byte universal character set, which is similar to UTF-16, but not quite the same. And there is an article here that you can take a look at that later on. But again, Unicode defines all character, or this encoding, this way of how you can transform this sequence of symbols into into machine internal representations. Okay, so Unicode defines all the character that we can represent universally in computer programs by assigning a specific number to each character or symbol, all right, called code points. So anytime that we talk about code points, is this encoding that is using is this internal representation of this internal representations in the computer sense of these symbols, and it maps that, right? So these numbers range from 0 all the way up to the maximum value of this, and hexadecimal is this, right? So you have 3, as you can see, if you have now 2 set of 3 values, in this case is this is the maximum number or representation. These numbers range from 0 all the way up to a maximum of this, right? Like 1 million, over 1 million, over 1 million it is, yeah. So over 1 million characters. Holy moly, you say that easy. So over 1 million characters. The standard notation for Unicode is characterized by U plus, like this. So followed by the 4 to 6 hexadecimal characters. Okay? So for example, to represent the hard symbol, right? So you need to know is the code point of this, whether it is on the whether it's so even if you want to get that representations, right, you can say, hey, please give me the code point at, right, and it's gonna give you is as a number, as it is, right. However, you can say, hey, give me now this character code at, which is going to give you now the same. But this is what it is, right? The code point at that position, right? Say 0 and 1, it's going to give you at that position. So because the first group of 65 535 code points in Unicode, it is called the basic multiplane, which contains all the characters known in the language, all right, and the symbols known from the humans here. So here you can now represent is up to this amount of characters or symbols here, and that include is the Western alphabet, whether it is Latin or English or Spanish or French or Portuguese, or even from the sub-Saharan or from Africa, also from the Eastern Europe, Cyrillic, Russians and Mongolian, and all the hand-based characters as well. And that also is the Hindu characters and all the different variation of that. So you get the idea, right? Uh, and also from the Thailand and the Southeast Asia. Uh, so all of this can be represented here, right? And this can all represents by 16 bits, all right? So 2 bytes. When representing Unicode character from the BMP, it is fairly straightforward as they can fit, right? As they can fit neatly into single UTF-16, right? I didn't quite what? When representing Unicode characters from the BMP, it is fairly straightforward. Exactly, it is fairly straightforward as they can fit neatly into the single UTF-16, right? So you can actually map one symbol from that uh, 16-bit representation. Okay, all the rest of the code points, right? Anything that goes above this 16-bit code enters now into the supplemental plane or the astral plane. And I really love about this name. I must admit, the astral plane, because it's like it is recognizing it is recognizing that despite that we have all of these different characters, we can even extend that, right, to express different stuff. So that means is, for example, not only this single character code, but also things like this, my friend. What it is? But things like the United States, for example. You see, look at where this enter here, right? And if I want to get is the what if I want to get is the hexadecimal, if I say string here, what if I want to get the hexadecimal code? Can I get that? Char add. So if I say something like no, but this char add. Okay, here is giving you now this Unicode representation that it can be either 4 or 6 hexadecimal. Okay, char at. Okay. Char at this table here. So here is this. So this is now the Unicode representation or the string representation or the encoding representations in JavaScript for string. All right, that's a very fucked up thing, I must admit. Absolutely, I must admit. But this is the whole idea here, right? So these code points require more than 16 bits to represent exactly, 21 bits to be exact. So when representing extend supplemental this astral or the character in the astral plane above the basic multilingual, JavaScript actually stores these code points as pairing of two adjacent 16-bit code units. So in other words, is that when you need to represent this particular character, so be internally is now has is 116-bit that represents the basic multiplane and this additional 16 bits, right? Or known as the surrogate pair. No, right? So for example, the Unicode point for this hexadecimal is the firework, right? So if I do want to actually get the Unicode point from that, okay, so what is the Unicode point of this So what is the Unicode point of this? And now it's telling you, hey, is this one really? It's the same? Oh, because you. Mm-hmm. But look at this. Look at this. The position 0 is the same as this one. All right. So the position 0 is the same, and as you can see, the position 0 is the same, right? But the position or the next position or the next 16 bits is different. Here is now this one, and here is now this one. So why am I mention this? Right? And also how you can represent some character, which is escape sequence. What the French stuff? Line continuation and multi-character escape. Is because anytime that we need to look, so anytime here that in Typescript here, we need to is represent a specific set of string values or type literals, and also we want to include is a string. So we say, hey, is this a specific values, and or you include also the string as well. So Typescript say, all right, I'll make my life easier. I'm going to pick the narrow one or the widest, all right, and forget about the others.
The way around this, which is
So
a famous
exactly. So how can we now actually indicate to Typescript, hey, I do want you to take in. I do want to. I just want you to note. I just want you to type in is these specific literals, type literals, and the string as well.
incantation that TypeScript wizards know about. So I will teach it to you here, which is if you wrap this in some parentheses, give it an and sign, and then
you're giving that. So if you do this, what the French stuff is this? So what it's doing here now, Typescript say, hey, this n is like a filtering here. So whether you take all of these strings, all right, grab the
then give it this empty object shape. For some reason, it just starts working. So now you get small, medium, or large in this particular slot. That's a fun little trick, but not one that I would introduce to, let's say, an application code base without some previous thought. And we will look at this syntax and what it does later, but I thought I'd just throw it in here just for a little bit of wizardry sprinkled in. But the main idea here is that you shouldn't think about literals and wider types in a union together in a way where you think, okay, it's either this or this or this. Really, all of these just get subsumed into string, and so you might as well just be typing string in these situations.
Yeah, but the key takeaway of this is anytime that you need to use literal typings with a string, all right, it is useful for us to, or you define just a string for Typescript, or you use that specific incantation of that. Okay. So narrowing union with type of. Why this is important? Again, because sometimes we want us to represent now piece of information in our systems that represent. So we want to represent piece of information in our systems of the ever-evolving business nature, right? And so sometimes it might be this particular piece of information. 6 months later, this now is a definition because let's say if you are in the real estate, so now regulation change and depend of the different state or county you live or province you live, now is apply certain restrictions and so on and so forth. You know, the business nature change, so we need to adapt to those environment. That is usually something that politicians actually impose, right? So in those scenarios, I look at why it is useful to understand these concepts of wideness and narrowness, and how you can use that whenever you need to define a specific subset of piece of information, or even using literals, and how you can combine that to define as a more wide types. So this is part of the union. And now I want to dive deep into the narrowing with the if statement and the type of. So let's get into this.
Now that we know about union types, it's time to introduce one of TypeScript's most powerful features, and that's narrowing. So here we have a convertTime function, and the convertTime function takes in a parameter of time, which is string or number, and we have an if statement here. The if statement checks if type of time is string, and if it is, then it console logs it, but you can imagine something else happening in here. If it's not type of string, then it still console logs it, and then it console logs it one more time. And if you think about this, if we call it with number, then this is going to resolve to false, which means inside this little bracket here, this little scope, TypeScript knows that this is never going to be a number, right? Inside there is never going to be a number. So if we hover over that, it's typed as string. TypeScript knows too that if this resolves to be true, this kind of type of time equals string, if that resolves to be true, then in the else clause, it's going to be false. So that means that it's going to be number instead. And then right at the end of this, because we're not like returning or doing anything inside here, then this time at the end is going to be still string or number because we're outside of this sort of narrowing scope. So you can think of here as these scopes as being really important in TypeScript when it comes to narrowing things down. If we add something else to this union, let's say we add a boolean there, for instance, now time is going to be still string, right? Because it's still checking if type of time equals string, but inside here it's going to be number or boolean. If we add in an else if and say type of time equals number, for instance, then it will be checked there and it will be number. Otherwise, we'll go else, console log time again, and now time is going to be boolean. Isn't this so powerful? And aren't your brain cells just sort of sparking with all the cool things you can do here? Type of is just one way that you can narrow down unions and narrow down all the different possibilities. And we're going to be looking at a bunch of different ways in the remainder of this section.
Again, that type of is something that come out with JavaScript, so it's not exclusively to TypeScript. TypeScript is just leveraging that feature, and the TypeScript server is just saying, okay, let me now is based on this, so based on that type of type checking, all right, now this is the proper shape of the data. And then conditional narrowing here.
In this exercise, we have a couple of things going wrong. We have a validate username function here where we can pass in either string or null, and it's going to always return boolean. We've added a return type to make sure it does. Now, what we can see is in the tests here, if we pass in some strings here, then it should basically check to see if the username length is more than 5. And if it is, then like with Matt1234, then it should return true. But Alice, because it's 5 or less, it should be false. And Bob, because it's less than 5, it should also be false. But how about for if it's null? What if we pass in null there? Well, this is the test that's failing. And currently we're getting a runtime error because we're passing in null, but actually username here is possibly null, and we're actually causing a runtime error by trying to access a property of null. So I would like you to rewrite this function to make this error go away. I just want you to mess about with the code that's inside this block here, and you'll probably need to use some sort of if statement and do a little bit of narrowing to make it go away, to make the test pass and to make this type error go away. So good luck.
Of course, let's get into this. Well, pretty straightforward. Pretty straightforward, right? You can say, hey, if now, so there are several ways. Oh my God, there are several ways to do this particular problem. And anytime that I encounter any situation like this, I would like to now is write it down what the French does is, but the possible solution, the naive approach, the naive approach. So here is you can say is using an if statement, using an if with type of to check if that if to check if username is a string, right? That's one. The other is so using an if to check. Okay, using an if to check if username is null. Okay. And checking is null. All right. That's another one. This is a string, or if this is null, right? There is another alternative here by saying something like this, right? And if this value is now undefined, right? So evaluate this here, right? So I just want you to evaluate this here, and if this gives you now a 0, now, all right. So in other words, if this give you now is undefined, which is a kind of it's a kind of emptiness, all right. If this give you now an undefined, or in this case null, right? So this will be evaluated to false, or in other words, this will be evaluated is to this null. But I want to coerce that, right? I want to coerce that value to a number, which means that when you evaluate this, since this is there is an issue here, but it say, hey, since this after I evaluate this, if this give me is now that's interesting. So look at this. So what is going to happen here is this. I'm going to evaluate here JavaScript, and whatever value I get, particularly whether it is a string, all right, yeah, whether it's a string, all right, whether it's a string or not, so if that exists, one way to do this is something like this. So if that exists, all right, so you either return is true, in other words, by evaluating is this statement here is either true or false, right? This can be also another alternative here. So no matter if you return me here this as a boolean, and I know that I'm confusing myself here. Let's do something like this. All right. So far I have these two alternatives. Okay. Whether if I check this with username as a string, okay, or check if this is a null. All right. Mm-hmm. 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 I think that's the two alternative here right now that I'm seeing. So the first is, hey, if this username now is equal to object, which is quite nasty. This is how you can compare this with null values. You can say, okay, let me now return is false here. You know, not at all. And here, I can say, hey, otherwise, all right, it's going to return now is this. So because now username here at this point should not be is that. So if username is now, is this one, is the type of a username is equal to object, which is JavaScript stuff. Hey, I want you to return false, or just return is this. I can even remove this, right? Because if not this, it means that it must be a string, therefore you get this, right? So this is quite interesting because this is known as the early return for errors. Okay, early return for errors. So if I look now here in the solution.
Okay, there are a bunch of different ways you could have gotten this right, so I'm going to go through 5 different options here. There are probably even more that I didn't think of, but the main idea here is that we want to check if username exists, and if username is a string, and if it is a string, then we basically return username.length greater than 5.
Exactly, this is another
Now you
one.
notice that I'm not doing a typo check here, I'm just saying if username. Wow, very, very cool. And this means, though, that it's filtered out the null version. The issue with this one, though, is that username, we don't have a test for this, but if we said validate username sort of like empty string, then it would return false. But actually, that does correspond to the way we want our function to work, because we only want usernames that are actually have length of more than 5. So this is the first way of doing it. We could also do it by checking if type of username is a string, and if it is, then do it that way. Beautiful. Otherwise, we could also check if type of username is not a string, because if type of username is not a string, then username inside here is going to be null, and we can return false, and it understands that after this early return here, where we've returned early, this username is now always guaranteed to be string. So clever. Next, we could do this. This is really quite nasty. This, we're relying on basically a bug in JavaScript where type of null is equal to object. And this now, type of username equals object, we're checking to see if username is null in a sort of very roundabout way. So inside here, username is null because string is not of type of object. And the final one here, we can even extract this check out into its own variable there and just say, is username okay? And do this check inside here. We can even do like a double bang username here, and this will still work because it converts it into a Boolean. And this means then that you can actually combine these different checks with other ones outside of your if statements to make your code a little bit more readable. You don't have to always inline the variable there. So this is really, really nice in terms of like our options are very, very wide when it comes to narrowing. And using if statements is a really clean way that you can make your types sort of feed into your runtime logic here. Because of course, if we checked if this was a number instead, which we're allowed to do, then actually like Is username okay is a boolean here, and username is actually typed as never, and we'll take a look at never in a bit, but it basically says that it's not what you think it is. It's not a string. So by actually having TypeScript back us up in this way, it makes our code a lot more robust.
That's interesting. This is the couple. Okay. So this is the couple alternative here. Silly ones for conditional narrowing in TypeScript. Whether it's check if username is a string, right? I do want to copy this. Check if username is null. All right. The other is check if username is check if username is not string. All right. Check if username is not null. All right. And the other is hold that reference, right? Check if username, and now the other is that hold the check in a variable or in an identifier. Okay, hold the check in an identifier and later use it, which I do find that is way more interesting approach by saying is, hey, is how do you call it, is valid username, right? And here I'm saying, hey, type of the username must be whatever validation you want to go with this, right? You can say, hey, is this different from or you can say if this is equal to string here, right? And here you can say, hey, if this is it, is valid user is that. I can now actually is return this one or false. But at the end of the day, what we're validating is this, right? We can also say, hey, in a more short syntax, to say, hey, is this one, right? Let's go to check this, and whatever value you get that, please give me this, otherwise just give me false. And in just one single sentence, I am now doing is this, right? So what it's going to do is to check that this is a boolean, all right? So for example, if I change that to a number and look at this, it say, hey, at the end of the day, I'm gonna get this as a boolean, but here it must be a parameter of never. And to me it's like, what the French toast? It means that this condition is never gonna reach to that number. All right. It means that this identifier will never have this property because it's does not exist. So it's going to return now false. But this is quite revealing here. All right. This is quite revealing here. So I also can say is, hey, is this username is different from object? All right. If it is, it actually goes to this one. But this particular approach to define is on, so to use our identifiers to compute something and then use that identifier to verify that is something that is going to increase the readability of our code, and that is appreciated for your future self and other developers. Got it. Got it.
There's a bit of a caveat here, which is when you're using the Boolean function, which ships kind of in JavaScript, then it doesn't quite work as expected. We noticed before that we could do this sort of double bang to make this work, where we're basically sort of converting username into a Boolean by doing this sort of like bang bang before it. Because if this one resolves to not username, and this one resolves to not username, which converts it into a Boolean and says whether it's truthy or falsy. But if we do the same thing by just applying it with a Boolean operator, it doesn't work. And that's because this is just a plain function. TypeScript is actually really good at understanding sort of operator syntax here by using or and. It understands all of those different combinations. But when you just use a plain Boolean function here, it doesn't understand it because it just thinks of this as a Boolean and doesn't understand that it's related to username. So while TypeScript's narrowing is extremely powerful, it does have little gotchas like this, which we will run into occasionally, and I'll point out as we go.
I don't like that kind of gotchas.
In this exercise, we're going to look at another kind of small gotcha when it comes to narrowing in TypeScript, where we have this process user map function, which takes in an event map, which is a map. And that map has a key, which is a string, and it also takes an event as the value. So this event up here has message string on it. So what we're trying to do here is we're trying to say if event map.has error, then we grab that message from the event map and then throw it. So your job here is to work out why this is failing. Why wouldn't this just work out of the box? Because we're checking up here if the event map has something with error on it. Surely it should know that event map.get error, like the map would have that error on it. So why isn't this working? Well, that's your job. And see if you can also refactor this to a way where we don't change anything about the outside of the function, but we still retain the behavior, and but TypeScript sort of narrowing works with us instead of against us. Good luck.
Oh, okay. So this is now a map here. You're saying, hey, there is a data structure in JavaScript known as indexed collection. Let me bring this up here, right? I didn't make this up. Just exploring here this key collections, where you have now map, sets, weak map, and weak set. All right. Also the structured data, but that again, this is index collection, which is when you have now all of these arrays, and the key collections. Okay, so this is part of the key collections. So let's get into this. There you go. And well, you have now this event map here. The map is string an event, and it's saying, hey, despite that you might have this, all right, to actually check that, somehow, and I am not able to identify, I am not able to retrieve the value of that and make sure that actually contains now this value called message here. Okay, and here's all about is narrowing this. Whether I can do is say this, whether I can say is, hey, this one, right? So now I make sure that, well, this value will be undefined or null, and I don't want that. Okay, so so what I can do here is to now well, try to narrow down that. So by saying is if now we're using as a key collection like a map, and that actually exists, so if I use now the event map dot get which is error, right, still somehow doesn't quite follow or understand that, right? Because it's saying, hey, this might be this might be undefined, all right? This might be undefined. So object is possible undefined with the get here, because it's saying, hey, I even though I can find it or not, all right? So um hmm and there's some couple types of, okay, object is possible null. Return specify is say the methods here dot get key string is the event or undefined. That's interesting. I don't know why get says that. Return and specify element from the map object is the value that is associated to the provide key is an object, then you will get a reference to that object on any change made to that object will effectively modify it is inside the map. So in other words, an object is possible here undefined. So so the thing here is that when it tries to read that, despite that it says AI has that error, okay. The problem here is that it's about properties in your map. So I can say now, okay, the problem here is about key values here. So despite that, that I am using the has property, Typescript is not able to recognize that, and instead it needs to you need to use this in property method here, right? So you say, hey, is error in event map? In this case, it's supposed to be like I think it's here. Whether if I use this, right, is the error in event map, all right? So if it is, well, let me now retrieve this get methods from the map. And it's a record error of unknown. So whether if you use now a hack to say, no, I know what is this. This will be now a string. Okay, whether if you use now a hack like this, right? Which is quite interesting, quite puzzling here. This method, it's saying that it's saying, hey, at some point this can be either event or undefined. So we know that the event map here at this point, okay, is this a string event, all right? It of course offers us this value here, But here these methods, right? It's a they I can't even find that or not, right? I can't even find it or not. So what I can say is, okay, if you find this, okay, and the error exists, so now I do one is to, well, uh, define here as a count of message, you know, message dot error dot message, you know, but you are narrowing things here as it is uh, like this. All right. So that's interesting. So we need to is move this line of code to throw this error here, right? Because at this point I don't have that message there. So whether if I do something like this and say, hey, message, and let me now down the row in a different scope, I define now is this message here. All right. So now this actually work as expected. But in this case, it can be a string or undefined. And in here is saying that is this message of any is now an string. But message say variable is used before assigned to. So it seems like Typescript doesn't like that. You know? Seems like Typescript doesn't like that. So what can we do here, right? So whether in this case we say something like this, all right? Hey, get that value, right? And if that value exists, so now instead of trying to hash or find it here, you just say this one, right? So if that exists, I want you to get that value here. You know, it's a possible object is undefined, and that's quite puzzling to me. That's a very interesting challenge here. It's like so you check it, all right? This is gonna return me is now a boolean that say, hey, that exists, okay? Yeah, go to with narrowing a map in a Typescript. So that exists, but then it say that it can be possible null because somehow it says that. But I'm saying here that this message event is in fact something that exists. But the problem here is with the map here. It's not with this property here, it's with the map instead. Okay. Yeah, the problem here is with the map. It says the object is possibly null. But if I say this, you get this, right? This is part of the map. That's right. Okay. And if I want to try to have access to those methods, it's like it's either throwing that on an undefined error. So I do get why you say that, but I'm trying to narrow here that here. So whether if I go and say something like this, all right, but unfortunately now the string this will be is a string or undefined, and what I want to do is to say, hey, give me then the error, okay, and if that error exists, okay, then I want to now then I want to go into the message here and say error.message as it is. So that's quite interesting. This is one way of how can I solve this, all right, especially for these key collections, map or sets. So you have to narrow down the value there.
Okay, the reason this doesn't work is because TypeScript doesn't understand the relationship between .has and .get here. It doesn't keep track on the map here what types are available on it, or what keys are available on it, or what keys aren't. If we were handling it like a normal object here, it actually would, and it would do a really good job. But we don't want to change the map, we don't want to do anything like that. So how can we refactor this code slightly to make it work better? To just hone that point more, this has function here, it just returns a Boolean. TypeScript doesn't know that that Boolean is related to that map in any way, and so when it tries to do the get here, it's just returning event or undefined. Ugh. So the way that I would solve this is I would first of all just extract this to a constant, and so I would just call this event, and now I can move this outside of the if statement here, and now instead of using the .has function, I can just check if event exists. And now if the event exists, we can see that like TypeScript is able to disambiguate between the event or undefined, and so inside this if statement here and inside this scope, it's typed as event. So this is the way that I would do it, just to work a bit more closely to what TypeScript sort of wants to do in sort of figuring out the relationship between variables, instead of relying on just methods like .has and .get. Not that you can't use those, but they just get a little bit annoying with TypeScript sometimes.
That's interesting, and it's because these key collections like map particularly, so it doesn't have any relationship about that. It doesn't have any map of your type here. So instead of relying on this, whether it's by refining that map down below, or by putting now or by extracting the value there as this, all right, and now you can have access to that event map here as it is, right? So now if the event map exists, so here you have now the event map dot message here, right? On the event map, I can say event, exactly. So to avoid overriding that, we can say event, and now it will work as it is. Okay, it's because it doesn't know about the relationship here. That's interesting. That speak volumes as well. Okay.
In this exercise, we have some code which is doing a document.getElementById app. And what this returns is a HTML element or null. So what we want to do is to make sure that app element is always defined. And we actually want to really, at runtime, make sure that element is defined. We could kind of lie to TypeScript using some techniques I'll show you in a bit, but we don't really want to lie to TypeScript. We want to make sure that by the time we're doing something to that element, for instance, let's say by this line of code down here, we want to make sure that it's definitely not null. And I'm going to leave it to you how we do that. You're going to be surprised by TypeScript's inference, I think, here. We actually want to, let's say actually we want to crash our app if app element is if app element is null, we actually just want to crash. Let's say that, and let's see how TypeScript handles that information.
So this is more like an understanding of throwing errors early by saying is that if the element does not exist, so now throw an error, right? So you can say is throw new error. So element does not, okay. So element does not exist, right? So if the element does not exist, you're gonna throw now an error here. This is if to detect some errors at runtime, and the other is the relationship with this key collection with the map particularly, and narrowing within statement.
In this exercise, we have a handle response function which takes in a type of an API response. Now, this syntax might look a bit confusing in the API response, but really it's a union between two different objects. We've either got this object where you can have a key of data, which is an ID of string, or we have an object which just has an error property on it, which has string. So inside here in handle response, we're basically trying to check if we're in the branch with the data attribute on it. And if we are, then we need to return the ID there. Otherwise, we want to throw an error with the response.error to make sure we're in that branch. But we've got a couple of errors showing here. The first error, we've got property data does not exist on type API response because property data does not exist on the error branch. Okay, that's kind of confusing. And this one, we've got the reverse error happening. Probably error does not exist on type API response. We've also got an unreachable code detected error here too, because we've just got an if true happening inside handle response. So this if true, then we need to change this to find the proper condition to do the narrowing here to make our tests pass, because our tests down the bottom are also not working. So that's your job, is to try to find out the right thing that you can put inside this if condition to make this all work, make it happy on the type level and make it work on the runtime level. There is a specific syntax I'm thinking about. Good luck.
It is interesting because here is something that we need to handle now is with objects. Most of the time we want to merge or define that this object can be one or another one, or this is the different the possible values that this type might be. All right. And because this is object and they now change that depending on the use case, depending of the business logic, so it makes a ton of sense to say things like this. Okay. So in other words, here we're gonna say is if you have now on the response, and this response now have different shape of the data, in our case, different shape of objects, I do want to now see if you have this particular property at that moment. And if it is, let's gonna do something with it. So if data is in the response, I do want to do this. Otherwise, it does not. And this is something that I'm gonna see a lot, especially when defining or when using is now instead of map is objects for to cover specific use cases. So for example, like API calls. When this data, so when I call this, when this is success, this is what it is. When this is an error, this is what it's gonna handle, and so on and so forth. Holy moly, bro. Okay. Narrowing within statement here.
Okay, the solution is this. You might think, oh, maybe we can change the type to make it a little bit different here. Maybe we can add like error is a string on side here. That might fix this branch. And then we could do like data is undefined or something on this branch. No, there's a much simpler way of doing this. And the way that you can do it is by, inside this if condition, saying if data in response, boom. What this does is it checks if there is a data key on the response here. And what this means then is if this resolves to true, it means that we must be in the branch where data is on here. If we had like a version of this where you could pass in data on this one, then it wouldn't actually like disambiguate anything. It wouldn't tell us anything because like data is available on both of the branches. But because data is not available on one of the branches, then it means that we get to narrow it properly here. This also makes our tests pass too. And it means that if we were throwing an error down the bottom here, then it's sort of, well, actually, because of the return statement, it does manage to narrow this. But if we were operating outside of an environment where we were narrowing, we would still just get this API response. We still have both branches available. But inside this else, it understands that if it's not the one with data on, then it must be the one with error on. And so the response inside the throw new error is actually just narrowing to exactly what we want it to be too. So this is a really, really useful piece of syntax for narrowing down objects that might have different keys from each other.
They might have different key from each other, especially exactly. And it's something that you're gonna see a lot of the time, especially due to this ever-evolving nature of the business, whether it's on real estate, aviation, so on and so forth, finance. So that'll be all for this video. Take care.